Hello students, in this video we'll see an example of how to use the joint probability distribution function of two discrete random variables to compute certain probabilities. Let's suppose that x and y are discrete random variables with joint PDF given by this table. So x will be over here. I'll put y down over here. So x can be either 0, 1, or 2. And y can be either 0, 1, or 2. So x and y will both be 0 with 0.1 probability. This will be a 0.2 probability. This will be a 0.05 probability. This will be a 0.1 probability. This will be a 0.4 probability, a 0.05 probability, a 0 probability, a 0.05, and a 0.05 probability. So for example, we can say that the probability that x is equal to 1 and y is equal to 2 would be equal to, x is equal to 1 would be this second column over here, and y equals 2 is this row over here. So when x is 1, y is 2, this is a probability of 0.05. And we can note that all the probabilities in this array add up to 1. If I have a 0.1, a 0.1, and a 0.2, that's 0.4. A 0.4 plus 0.4 is 0.8. Then I have 4.05, which is a 0.2. So they all add up to 1. Therefore, this is a valid joint density function. Let's now find a couple probabilities. Let's first find the probability that x is strictly bigger than y. To do this, we note that this will be the following. This will be the probability that x is equal to 1 and, well, if x is equal to 1, y would have to be 0, plus the probability that x is equal to 2 and y is equal to 0. That would also be an event that counts. Plus the probability that x is equal to 2 and y is equal to 1. In other words, when is x larger than y? X is larger than y, not here because x and y are equal to each other. When x is 1, y is 1, and y is 0, that counts, so this value will work. When x is 2 and y is 0, this will work. When x is 0 and y is 1, that will not work. When x is 1 and y is 1, that will not work because they're equal to each other. So when x is equal to 2 and y is equal to 1, that will also work. And then when y is equal to 2, it can never be less than x because x is always less than 2. So we add up these three probabilities. So this first probability over here, x equals 1, y equals 0. So when x is equal to 1 and y is equal to 0, we have a 0.2 probability. This probability over here, x equals 2, y equals 0, corresponds to a 0.05 probability. And finally, x equals 2, y equals 1, so x equals 2, y equals 1 has a 0.4 probability. And therefore, we have a 0.65 probability that x is larger than y. Let's see another example. Let's compute or find the probability that x minus y is equal to 1. Well, now we look at our chart. So when can x minus y be equal to 1? Well, there are several times this can happen. This is equal to the probability that x equals 2 and y equals 1. Because if x is 2 and y is 1, the difference will be 1. Or I can have the probability that x is equal to 1 and y is equal to 0. And those are the only two ways that x minus y can be equal to 1. Because if x is 0, for example, then this expression over here can never be equal to 1. If x is equal to 1, the only way that x minus y can be equal to 1 is if y is 0. So this value will work. So this is one of our blue values over here. And if x is 2, then the difference can be 1 only when y is equal to 1. So this value over here is the other blue value. So these two blue values, we see this first blue value over here is a 0.4, and the next blue value here is a 0.2. So there is a 0.6 probability that x minus y is equal to 1. In general, when we're given the joint PDF of two random variables, and I'm asked to find the probability that some event happens, we look at the array and we circle the members or box the members in that array that satisfy the condition inside the probability. The rest is just simple addition. Thank you very much.